Good. 2 of you are great. Glad to hear that. My name is Eric Johnson, and I am glad to be here. I'm excited to be here at serverlessDays Nashville. I want to take 2 minutes or 1 minute or whatever and say what an amazing job the organizers have done on this. Give them a round of applause. Yeah. Been to several of these. They're great, but this one was well organized, well executed. You guys get to be here and see crazy people like us, and we get to see crazy people like you, and it's exciting. So thank you very much. We are going to be talking today about thinking asynchronously. That's a word that I barely know what it means, but somebody said use it. So I want to challenge you when we're talking about serverless on thinking asynchronously. Now, let me tell you a little bit about who I am. I am Eric Johnson. I'm known on Twitter as EDJ Geek. I'm also a whiner about pizza and pineapple and orange juice with pulp, things like that. So if you follow me at all, you get that kind of complaint. I'm going to just rest it right now and say pineapple should never be on pizza. Okay, I expect an applause there. That's right. Okay, yeah, for those of you who are booing, there's the door. So, no, I'm glad you're here. I am a senior developer advocate for serverless at AWS. I love serverless. I've been doing serverless since it was announced. The first day I heard about it, I said, why would you do anything else? I am a serverless fanatic. I've been a software architect, a solutions architect. I'm a husband and a dad of 5. That's not a typo. I have 5 kids. My wife is a superhero. So, now, has anybody here heard me speak before? Okay, a couple of you. How many of y'all know the rules? All right, couple, even those. Okay, so there's a couple of rules to when I'm speaking, and I know you're probably thinking, wow, who are you to make the rules? Well, I'm the guy with the mic, okay, and I'm probably the loudest person in the room. But these are the rules, and they're really more like guidelines. They're going to help you out, okay? The first rule is this. This is any number I want it to be. Okay, some of you are like, can we laugh at that? Is that funny? Yeah, it's funny. It's okay. I was born with 1 finger on each hand, 1 toe on each foot. You watch me walk, I get going too fast, I will fall over. It's just the way it goes. That's a balance thing. I do make 1-finger jokes. I'm completely comfortable having 1 finger. I didn't wake up this way. No, I did wake up this. That would be weird. If I did wake up this way for the first time, I would not be here with you. Okay, I'd be somewhere coping, all right? So, like I said, I make 1-finger jokes. I'm comfortable with that. If that makes you uncomfortable, I'm also comfortable with that. So I'm going to be okay either way. So second rule is this. These are quotes, not apostrophes. I know that. I guarantee you somebody will come in later and I'll use my standard, I was working, and they'll be like, is he waving at us? I'm not waving at you unless I am. It's contextual. You have to figure it out. So the final one is this is thumbs. I do this a lot. If you take a picture with me, I'll do this. And you'll show your friends, like, why is he pointing at himself? He's really arrogant, which is not untrue. I'm not proud of that, but there it is. But in fact, my college ID was that. I'm the only one they let do that. So anyway, that's a little bit about me. I am an avid Dr. Pepper fan, so if you ever want to bribe me, there it is. So let's get started. When we think about serverless applications, there it is. I just started up again. Apparently, I talked too long and the remote went dead. There's some common serverless patterns. And this is more when we're thinking about maybe some web applications, right? And so they look like this. Very simple. You know, you have your API, you have your compute, you have your warning, and they each have some different roles. Your API, you're going to do some security, some routing, different things like that. With your storage, it's going to do storage, so that's pretty self-explanatory. And then we put in the middle our compute that does everything else. How many times do we reinvent the wheel in our code? Raise your hands, every one of you. Okay, you're the not liars in here, okay? Because we do. We tend to take on a lot in our code that we really don't need to, right? So, here's kind of what I look at on this, and this is the order that we do this. We have API, we have compute, and we have storage. But here's the problem. And it's not really a problem, but it's something to think about, okay? If something's going to go wrong, that's the place it's going to happen. And let me tell you why, okay? This is a deep secret that you're going to want to keep to yourselves. What happens in serverless days stays in serverless days until you're able to tweet it, right? Okay? Here's the problem with this pattern. It's my code, right? My code is not the best. Okay? I'm a developer, and in this room, I'm probably the 72nd best developer. okay? But my code is not always the most solid thing. And I can guarantee you with the cloud providers that we have, their managed services are going to be more solid than my code, okay? So how do we improve on this? If we think about it, we have API, we have compute, we have storage. How do we improve on this? Can we start the clock? Because I guarantee you, I'll just keep talking all day. Be like, I'm sorry, guys, I have 50 minutes left. So, all right, so how do we improve this? Well, today I'm going to challenge you to think about going storage first, okay? How does that work? And so let's think about thinking synchronously for a minute, or I'm sorry, thinking asynchronously. What does this actually mean, okay? Well, like we talked about, we have this order, and when we start thinking about asynchronously, we're going to store first and process after. Now, I know you're thinking in your head, that won't work with my application. And you might be right, but you might be wrong, okay? Because there are some ways that we look at this that we can think about, how can we make this an asynchronous application? How can we make it work? And here's some advantages if you think about it. First of all, you have greater reliability. If I can get the user's data into storage before my code gets its grubby little single fingers on it, then I'm going to be more safe. Because here's the deal. If my code tanks, even in the retries, I've tried it. Of course, I test my code in production. And don't, yeah, come on. Some of you are like, we don't do that every time. But I have greater reliability because the data is stored. If my code tanks and I need to go back and get the data, I don't have to go back to the customer. Hey, I lost your data. I'm sorry, my bad. Give me another shot, right? That data is sitting in my storage, right? Okay, the second thing is less code. When I'm integrating directly, when I'm taking my API and I'm integrating directly with my storage, generally, I have to write very little code for that to happen. And what's the enemy of Eric's greatness? His code, right? So I want to do as little code as possible. I'm also lazy. That's the truth. My wife will be here going, that's true. Okay? So if I can store first, I'm using less code. Here's the next thing. Faster response time. I have seen, and I'm going to do an example of this in a little bit. We see these applications where you go, okay, give us your code, and then we're going to boil the ocean while the little ball's spinning on your thing. And we're going to make that animated GIF as exciting as we can so you like it. You're like, I just want to do another one just to watch the animated GIF. Right? This is exciting. And then we're going to give you an answer back. And your client, what's the reality of that? The reality is, I don't know what the exact metric is anymore, but it's like if my kid does not see a website respond in 2 milliseconds, he's gone. It's broken, move on. That's the truth. That's the reality we face, isn't it? On our websites, if I click, nothing's happening here. Still broken, okay? So we need to get our customers away from that, right? So when we do things asynchronously, we can drop it into storage, get back to the client and go, hey, I saved it, move on, we'll get back to you. Right? That's thinking asynchronously. Does the client need to wait while all the work is done? So for those of you who are saying, this wouldn't work with my application, I ask you, does the client need to wait while all the work is done? Or can we get back to them and say, hey, we're working on it. We'll let you know when we're done. All right. Processing after. Okay, so what does that look like? Well, here's the advantage. When you're processing after, you can do more. Yeah, and you're like, well, you can't. So let's go back to our scenario again. If I'm doing it all synchronously and trying to get it to my client, I can still do a lot of things, but everything I add adds time, right? And we've already established with all authority that clients don't want to wait, right? But if I send it back to my client and I say, hey, we got your data, we're going to do the work, then we can do a lot of things. And especially when we're doing serverless, we can do a lot of things in parallel, can't we? We're able to say, I'm going to do this, and I think I'll do this. And I'm going to do this, and I'm going to do this. So you can do more without having to wait on it. So you maybe say, okay, Eric, that's great. I love it. Thumbs up from me, metaphorically speaking. But how do you make this work? Okay, how does something like this work? And you've heard today, I've heard some great presentations that talk about event-driven architectures. Now I'm gonna do a quick poll in the room because I'm curious of where we are in the room. How many of y'all are using serverless right now? Okay. How many of y'all are thinking about serverless? All righty, good, okay, good. How many of y'all didn't realize this was a serverless conference and came for food? All right, there's always one. Did you get fed? Okay, great. Now, hey, get this man some food and then get him out. All right, so when we talk serverless, we talk event-driven architecture. Okay, the way we describe serverless is kind of fun. It's going to make it work here. The way we describe serverless at AWS is, and this is, I'm really sad that nobody has pen and paper out, but whatever. This is really deep, okay? These are the good notes. Here's serverless. Something happens, we react, and do something. You want me to repeat that? Okay. Something happens, we react, and do something. There you go. Have a good day. Okay, that's serverless in a nutshell. And the idea is with this, and usually that's Lambda. You heard, on AWS, that's going to be a Lambda function. Something happens. We drop data in a bucket. We have put something in DynamoDB. We do all kinds of things. And then the Lambda goes, hey, there's something happened. I'm going to do something. And then we do some kind of action you can do. It's really, you're really limited by your imagination. And that's how it works. So let's look at how we can make that happen when we think about the storage first option. Okay? So on AWS, here's how to do this. And you can take it and look at on other services as well, but I work for AWS, and that's what I know, and that's how I'm going to show you how this works. But this is what this looks like, just this particular example on AWS. Okay? So we're going to use services like API Gateway, Amazon DynamoDB, and Lambda functions. Okay? If you're not familiar with these, Amazon API Gateway is a little service that we like to use that fronts, and you actually create an API, you can manage, and you can do a lot of things with API Gateway. If you're writing your own API Gateway and you're handling your own routes and things like that, I would stop, especially if you're in serverless. There are services that handle this. At API Gateway, I can manage, he's like, hey, this is Eric here, I'll do it for you. But API Gateway can handle throttling, caching, authentication, just numerous amounts of things, custom domains, all kinds of stuff, all right? The other service we have is DynamoDB, okay? Anybody ever heard of a company called Amazon.com? Okay, they have this thing they call Black Friday or Cyber Monday. Anybody ever heard of that? It's a startup. It's all right if you haven't heard of us, okay? But we found that we're getting a certain amount of traffic, okay? We're moving and grooving, okay? And in order to handle that, we use DynamoDB. Okay, and that's a high input-output service that allows us to handle it. And finally, Lambda function. And the Lambda function is the compute, all right? So that's how we do this when we're building that out. So how does that kind of put together? So we have this thing with the API Gateway called service integrations. Has anybody heard of VTL? Okay, good. All right. How many of y'all hate VTL? Okay, same hands. That was fun. Okay, it's not the funnest thing in the world, but it's very powerful. And excuse me one second. VTL stands for Velocity Templating Language. Okay, and it's made by Apache. We support it on Amazon API Gateway, and it gives you the ability to directly integrate with services. All right. Now remember, one of the goals here is for us to talk directly to storage from API. Okay, so because we want to do our processing asynchronously. So API Gateway does a service integration and talks directly to that. With API Gateway, you can communicate with over 100 plus AWS services. So this is just an example. Okay, there's a lot more you can do that. You can modify requests, you can modify response, you have all kinds of power. Okay, the second part of this. Now we talked about when serverless works, something has to happen. We recognize it happened and do something. You guys remember that? So when I drop data into DynamoDB, that's something happening, right? Okay? So I can actually, this screen's dead. That screen's dead. We got screen's dead. All right, I'm going to pantomime it. No, I'm not really going to do that. I'm going to have fingers. Okay? All right. Sorry, I didn't mean to call it out, but yeah. It is still plugged in my laptop. I'm gonna tell you what it is. It's doing a wiggity thing here. Hang on just a minute. Okay, you got it? Here's what it is. I've done the sleuthing and I've figured it out. The stage is not built for fat people. So I am fat enough to disconnect my monitor, which you may think is weird, but I'm kind of proud. I'm like, yeah, you know. Anyway, all right, so if it goes out again, that's what it is, okay? So the second thing we have is we're going to do this thing called DynamoDB streams, okay? And what that is when I drop data into Dynamo, it's going to then write a log out the backside of it, okay? That's a really technical term. It's actually more technical than that. And I can trigger a Lambda from that. I can say, when I drop data in, do this, okay? So now I have the power. So you figured out, I now have the ability to say, now that the data is stored, I'm going to do something with it, okay? Now, DynamoDB is not the only option. It's the one that I've chosen for this particular exercise. But you can do that with Amazon Kinesis. You can do it with SQS. You can do it with simple storage with S3. All of those have the ability for me to drop data in and then do something, okay? So as you see this, you have this idea of, okay, now I have the ability to trigger something after the fact. Okay, so no more excuses for saying, well, I can't store it first. So there's different options. So let's compare these and how they work, okay? Let's look at a synchronous application first. So I wrote this application, and it's a translation application. And the idea behind it is I'll show it to you as we go through. This is the data that you put in. You put a string of text in, hello, welcome to translation demo, and then you give the cultures, okay? So I'm going to say, these are the different cultures, all right? So here's how it's going to work. Okay, number one, each culture is sent to Amazon Translate as a separate request. Okay, so the user commits it to API Gateway, and it hits a Lambda, okay? Then it will send it for translation. And it'll actually break out each one of those cultures and send them as an individual request. So in our previous example, we have 3 cultures. We're going to have, I'm sorry, I can only count to 2. Okay, we have 4 cultures. Okay, I could get to 5, or I could get to 4 if I take my shoes off. That just got weird when I said 5. That was weird. All right. I'm going to tell a side story, okay? Because that's who I am. When I had my first kid, okay, when we were having our first child, we went and saw a genetic specialist. Personally, I was like, whatever, But my wife was like, no, I'd like to know what's coming. I was like, okay, that's fair. Okay, so we went and saw a geneticist. Is that the right word? I don't know. I'm not good with the words. And so he said to us, here's the deal. He said it's a 50-50 chance. Every time you have a kid, they're either going to have 5 fingers or something else. And I was like, what? Hang on. So 5 fingers or 1 finger, right? Nope, incorrect. 5 fingers or something else. I'm not kidding you. And I know the irony of this, don't judge me, but I was like, ew. 2 finger, ew. That's gross. So there's no point to that, and I owe all of you 30 seconds of your life back, but there it is. So I can get to 4 if I take my shoes off. Okay. All right, so each culture, it's broken out. It's going to make 4 separate requests to translate that bit of string into whatever culture we request. It's going to then return that data to the Lambda. That Lambda is then going to take that data, and it's going to send it to Amazon Polly. And what Polly does is it takes that text, and it translates it into the language. And I can set, voice. There's some controls I can do. But it actually makes an audio file from the translation, okay? Then the next thing it's going to do is it's going to take the stream that comes back from Polly, and it's going to drop it into a Dynamo or to an S3 bucket. All right? So what we've done so far is we've created a translation from each culture. Each culture has then been converted to an audio file. That data has been dropped into a bucket. So we get all that information back, and then we write it to DynamoDB. Now here's the issue, okay? So what if I can line this up. Ooh, there it is. What if it breaks there? Okay, well, I got to go back to the customer and say, I lost your data. okay? I'm not going to try to point again because I'm not accurate enough, okay? Same with Amazon Poly. There are several stages where my application can break. Now, you may be thinking to yourself, and I know you are, it's AWS, things don't break. What was the laughter about? Okay, here's the fun thing about AWS. If you don't know this, we're pretty open about it. We build as if things don't break, or we try to build things so they don't break, but we build as if they will. Put it better by our CTO, Werner Vogel, said, everything breaks. Okay, so the reality of life is sometimes it doesn't work. Okay, race conditions, code issues, resource issues, Eric Johnson's fat finger issues. Okay, things break, right? So what we try to do is we say, how can we build an application that survives things breaking? Okay, and this is not, while this would work, it's not the approach that says, hey, I'm more resilient, because what I've introduced is at least 4 or more, if you're thinking back and forth writing, areas where that can break, where I got to go back to the client. Now, yes, we've built in retries. We have lots of things that are built into Lambda that are built in that help you control this. But if I've already got the data stored, I have more chance of not looking stupid to the client, don't I? And that's what it's all about, right? Okay? So let's break this down and look at it. First of all, let me show you what the data looks like. And I was telling some folks, I had some dinner with some of the serverless heroes last night. I was telling them I was so proud I used a sparse index, and there it is in DynamoDB. It's not that impressive, but it is impressive if you know me. Like, oh, he's impressive because he figured that out. All right, so in DynamoDB, this is how it's being written. Each translation is written as its own record. I'm using an index here. I am just positive that Jeremy Daly later is going to tell me how I could do this way better, infinitely better. I would tell him he's wrong in public and beg for his help in private. So, and then you have the audio files that are saved to S3. Okay, so this is our output data. Okay. So let's look at this. So we did this synchronously. What would this look like asynchronously? All right, same application. Now don't get scared. There's going to be a lot of lines in this one. Okay, lines don't hurt us a lot. Okay, so hang in there. All right, and I'm walking as gently as I can so the screens don't go out. All right. So first of all, instead, just like I said, we're going to take this data and we're going to go into API Gateway and we're going to write it straight to DynamoDB. Okay? And at that point, customer's going to get a response. Hey, we wrote it, we're working on it, have a great day, you look lovely. Okay, you don't have to do the you look lovely, I just like to say that. Okay, 1, original request is written directly to DynamoDB. 2, what we're going to do is out of that stream, because I need to break these apart, I need to do a little logic on it, I've actually put a Lambda here, okay? And out of that stream, that Lambda, I call it my stream reader, he's going to break each of those cultures into requests, but he's not going to talk directly to the translation. He's not going to call translate. He's going to put those requests into Amazon Event Bridge. And if you were here earlier, James talked about Event Bridge and how that works. It's an event bus, right? So those requests go in. So now what we've got is if we had 4 cultures, we just had 4 different translations being requested. Okay? All right, so the next thing we're going to do is number 3, based on the event rules. Okay, so we're going to write some rules in Event Bridge, and we're going to say if it's a translation request, grab it. This Lambda is going to get triggered, make the translation, and write it back to DynamoDB. Okay, so I'm doing some post-processing. If that fails, I can actually write it back as an error and say, hey, you need to work on this later. But I have all the data to try it again, don't I? All right? So the next thing that's going to happen, number 4, each transition triggers a stream reader function going through, and again, we're going to have an audio request. So it's the same process. Oh, more stuff has been added to DynamoDB. I'm going to grab it, and I'm going to push it into Event Bridge. Okay? Same process, but a different rule. Okay? You're starting to see a pattern here, aren't you? Okay, something hits DynamoDB, and the stream reader pushes it to Event Bus, and we have a rule. So that rule is going to do create an audio and drop it into Amazon Poly. Something cool about Amazon Poly is I can have it say, make the audio file, and drop it in a bucket when you're done. I don't have to sit there and spin, and I don't have to use milliseconds of Lambda time and storage while it's working. I can just say, here it is, do your thing, have a good day, okay? But what I can do is then, when that file is done and hits that bucket, I have another Lambda that's triggered that finalizes everything. And it takes that data and writes it back to Amazon DynamoDB, okay? Same process, but broken across 4 Lambdas. Now, if you're new to serverless, you might be thinking to yourself, whoa, that's going to be 4 times as much. And I'm going to tell you, not true. It's going to be 1 time as much. Okay? That's the only one I can really do. I'm proud of that one. Okay? And here's the reason why, depending on how you use. So Lambdas are charged by the invoke count. So yes, 1 invoke versus 4 invokes. But they're also billed by how much storage time do you use. Okay? So the longer it runs, it costs a little more, right? So when I'm doing short bursts of boom, 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 versus boom, wait, then go away, the pricing is very close to the same. All right? Now, and these are going to be very short bursts because all we're doing is just passing some text around, right? That's all we're doing. We're doing it asynchronously. So let me show you what this actually looks like, okay? So we have this address. You're welcome to hit it on your phone or do whatever, but I'm going to show you up front here. Okay. Now, I know right now you're saying to yourself, I can't see a thing, and so I'm going to fix that. Hang on a second here. In show. Yay. There we go. We all see that now? Okay, let me blow it up a little bit here. Okay, I know you are thinking, wow, that's an amazing design. I designed this website. I did used to work as a designer, and I'm pretty impressed with my design. I do not hire out, so this is our website, and okay, right now we're looking at the Synchronous version. I can switch back and forth, but I'm going to go in here and let's go to, I don't know, we'll go to aws.amazon.com/blog. I'm always scared of, oh, I have no internet. Hey, I don't need the critiques, people. I know, I mistyped. Hey, I fixed it. Thank you for telling me, whoever told me, I appreciate that. All right, so we're going to go to the AWS Heroes program, hey? Okay, look at here. Just real quick, we're going to take this minute. Is he in here? Is he in here? There's some new heroes. There he is, Ben Ellerby, who is at this session. He was called out as one of the new serverless heroes, so just so you know that. That's not why I'm here. But let's take this amount of text here, okay? All right, and we're going to go here, and I'm going to create a new one, okay? And what I'm going to do is I'm going to enter that text, okay? And I'm going to say, I want you to translate it to all of these different languages, okay? So let's go. Translate. Okay, now at this point, I do something fun and hope that it maybe works while we're waiting. I have the 3 little dots, so you know I'm waiting. It's by this point, there it worked. Okay, so we got back to the client. That wasn't horrible, right? So let's go back into here, okay? And I'm going to turn up my volume. Well, I don't know if you'll hear it or not. I'm going to repeatedly turn my, hang on, this whole thing. Okay, so. Okay. It worked, okay? I told you that would work. But if I were to run this at load 1,000 times over and over, something's probably going to happen, okay? And it'll be AWS. It won't be my code, okay? We don't need to record that. We'll edit that out, right? Okay, got it, okay. All right, so it worked, all right? But let's look at it asynchronously, okay? We're going to take the same amount of code, or same amount of text, I'm sorry, okay? And we're going to switch to asynchronous and go back. Okay, I'm going to create new. And all I'm doing is changing the endpoint on the backside, okay? And I'm going to do this here, and I'm going to translate, and we're done. Okay, my client's got a response already. Now I'm going to go over here, but not everything's rendered. But you know what? That's okay, all righty? Because they're getting a notification saying, hey, we're working on it, but it's going to come back to you in a minute. All the translations happened right away, and in a minute you'll see the audio renderings pop in as well. But clients aren't as disturbed. There we go. So it's all done. Clients aren't as disturbed to see that as they are the, why is this spinning so long? It must be broken. Let me hit it again. Let me hit it again. Did that double bill my credit card? Have we seen things like this? You know, so it's an uncomfortable process for clients to work with, okay? All right, so that is asynchronous versus synchronous. But let's take a look at this and see what else, now that we've kind of got there, what else can we do with this, okay? So we've built what I think is a more reliable way to applications. Do I think it's going to fit 100% of workloads? No, I don't, okay? But do I challenge you to evaluate your workload to see if this is going to work for you? Absolutely. Okay, because reliability is something we want to build in. Reliability is something that clients and customers are looking for. So how do we make this one more reliable? Okay, well, so let's look at our architecture. Okay, we have our architecture here, and you think about it, we've got 4 lambdas that are running, and in each and every one of those lambdas, they're handling code and they're doing error handling, aren't they? And a lot of times that error handling is going to look the same. It's the same error handling, but and we're doing that. So we're duplicating. You ever heard the principle of dry? Don't repeat yourself, right? So we don't want to repeat ourselves. And we find ourselves repeating ourselves. Allow myself to introduce myself. Okay, if we find ourselves repeating ourselves, I'm just going to commit to it, then we need to evaluate our code and how are we doing this. So we got this really cool thing where we want to say, what if we could have one lambda handling our errors and the other ones don't have to do that? What if we can offload our error handling? Well, we just came out with this thing at reInvent last year called Lambda Destinations. Okay? And the cool thing about Lambda Destinations is that you can say, hey, if it fails, do this, or on success, do this, on fail, do this. And you could go to any multiple of endpoints, right? So you go to Amazon EventBridge, Lambda, whatever you want to do. In this particular one, I'm just pointing it to another Lambda, and it's going to pass the event data and the stuff that's required to handle the error, okay? So let's go back to our situation here. Okay, so I've got these 4 Lambdas. What if I added a 5th one, and I routed all my error handling to that 5th one? Okay, so now what I've been able to do is reduce the amount of code that each Lambda is working on. And what is one of the things I talked about? We want to reduce code. Okay, that's a thing for us. We want to reduce code as much as we can. So when we take and we plug that back into our architecture, then what's going to happen here is we have this ability to say, if translate fails, or stream reader fails, or audio fails, or finalize fails, send that data over to my error handler, okay? And all he does is he says, okay, I got it. I'm going to go ahead and write that back to DynamoDB with some kind of error flag. Okay, you following me? So then what I can do, if I want to start really controlling that, is I add an error. What did I call that? Error, code error, whatever. Well, I can't read that up there. It's in front of me. I got it. He's not smart, is he? Okay, the cron error correction Lambda. Okay, so what you're able to do with this is I can run this every 10 minutes, every 2 hours. With mine, I'll probably run it once a week because errors just don't happen. But they might for y'all's codes, whatever. But so what you're able to do is say every 10 minutes, check the database for errors and retry or notify someone or whatever. Okay, so you're doing some retry logic on your own. Now, a great conversation with Jeremy last night, we were talking about, if you were to do SQS, you could take it, instead of Dynamo, you could take advantage of some of the retry stuff. There's lots of angles you could take this. This is just ones I happen to be talking about because I have control over this, right? So you're getting into a lot of resiliency here and somewhat, dare I say, self-healing, okay, where your application say, okay, I got an error there, let me try it again. Or you can write some logic in that could decipher. For mine, one of mine is, and I really ran into this, is I had a wrong culture type. I had it available, and it was putting that culture, and then every time it ran, it blew up. And I thought, man, AWS is breaking a lot. But it wasn't. It was my culture type. And I had to change that and fix that, right? So I had the ability to go, hey, here was the issue, write it out. Of course, using logs and stuff helps a lot too. All right? So let's go back to this pattern idea that I was talking about, okay? The idea is we have a pattern, we store the data in DynamoDB or some type of storage. Like I said, DynamoDB is the one I chose for this application. But think about how you can make that work for you. And it depends on your workload and what you're doing. Do I need that longer lasting static data in Dynamo? Can I have it in Kinesis? Can I have it in SQS and so on and so forth? Okay. Then I analyze the request and insert it into Event Bridge. And then using event rules, I trigger different lambdas as those come through. Okay. And then finally, I write the data back to Dynamo and then send all errors to a Lambda function. So this is this pattern that I can now grow my application on as I'm growing further and further. So what if I want to extend this, okay? So now that I've gotten this pattern, what if I want to, let's say, understand the sentiment of the content being translated, okay? Someone sends me some content, I want to check it and make sure they're not calling me bad things before I publish it, okay? All right. So what I can do is I can take and I can use Amazon Comprehend, and I can put that up, and I can say, all right, we're going to use Amazon Comprehend. It's another service. So how do I tap into it? Well, we follow the same pattern. I throw another rule on Event Bridge, okay, that says, hey, when you see this, get the sentiment. I can do it just on the original one. I can say it has to be the original request, so I just translate the English or whatever language I'm doing, or I can do each one. So I can see if maybe my translation isn't what I meant for it to say. Okay. The second thing I can do is then it puts that out to comprehend, and then it writes it back to Dynamo, and then I hook it into my error lambda. So half the battle of development are patterns that work, right? Is figuring out what's a pattern, especially when you're working across teams. What are the patterns that work? And then when you do that, then they become scalable. Okay, I plug this lambda in. Here's the rule. Here's how the errors should handle. There we go. All right, so I can build this application out as far as I need to go. All right. So again, yeah, look at the lambdas here that I just talked through. So let me wrap up a little bit. Here's the thing I'm building resilient applications, okay? Thinking asynchronously, I really challenge you to do that, okay? And it's sometimes a different paradigm. For some of you, you're like, this is not new to me. I get it. But I'm guessing for some of you, it's like, I never thought of that. I haven't processed this. And with serverless applications, it's very easy to do. It's very easy to go, I can build this asynchronously. I can build this and do a lot after the fact. The second thing, you'll see my hashtags a lot on this. I say storage first, okay? If you can store it before you work on it, do that, okay? So that goes right in hand with thinking asynchronously, and I get that. But sometimes we don't get this idea of, all right, I'm going to store that data so I have access to it in case something goes wrong. Because, and all joking aside, things break. Something goes wrong. And finally, use less code. James, I really appreciate his keynote this morning, and as we were talking about it, one of the things as developers, especially as serverless developers, is we start to understand that serverless applications are often a chaining together of managed services, right? Okay, they're often saying, for this managed service, I'm going to use this, and for this, I'm going to chain these together. And so what we don't want to do, and I started this out in the beginning, is we don't want to reinvent the wheel inside of our code. So I challenge you to evaluate, regardless of the cloud provider you're on, evaluate the managed services that are offered and how you can use them and how you can use them to the most benefit, right? Because more often than not, something as simple, I'll just ask this question in this room. Let's see how they do it. How many of y'all run a cron server? Okay. Some of you, there's a couple of people like, and then they're looking around. Okay, I've run cron servers. Did you know that with Lambda, you can do a timed event and do the same thing you do in cron, and you only pay for the invoke, and you get 1,000,000 invokes free per account, right? So you can have free cron, basically. Okay, I say that to say, sometimes it's awareness. I didn't know that. I didn't know it can do that. API Gateway, I can go on and on for different ones, but API Gateway can take so much load off your code, it'll shock you with authentication and throttling and caching and so on and so forth. So bottom line is understand the managed services, because serverless architectures are chaining together of managed services. If nothing else answers the question or answers the solution, then code it. Okay, and that's for some of you. All kidding aside, most of you are probably stronger developers. I'm a good developer. I can hold my own in my household. My 9-year-old and 7-year-old, they don't have a chance. All right, like, we don't care, Dad. Can we go back to cartoons? No, it's a contest, so Daddy's better. Okay. Sorry, there it is. But my challenge to you is figure that out. Last option is write code, okay? Because a lot of times those solutions have already been done. If you're wondering about serverless on AWS and you're new to it and you're thinking, wow, where do I get started? It's a good place to get started. Okay, it's a place where you can go, okay, I'm not sure how to do this, but I want to get started. Also talk to me, talk to James. We're here. There's an AWS table out there. There's one right back there. We can answer your questions. We can help you get started. One last thing I would ask you to do is we always want to make these better. We want to know, and I'm sure in your survey you'll be like, stop telling weird stories. That's fair. But I'd love to hear your feedback if you have time. Let's just take you to a survey, take a picture of it, and fill it out. There's no prizes. I'll hug you. And that's it, and I'll tell you, I'll leave this up so you can get pictures of it. I am EDJ Geek at the bottom. You can see my Twitter. If you follow that, you'll hear a lot about pizza and orange juice and all that kind of things, but you'll hear a lot about serverless. You'll hear a lot about my family. You'll also hear a lot of serverless for everyone. I think serverless can handle, I really do think it's the future. I think it is where the end game, at least right now, is. And so I do serverless for everyone. I've got some stickers up here. If you want them, you're welcome to come grab them. With that, I'll leave it to you. You guys have a great day. Thank you. Have a good serverless days.